Okay, so now we're gonna build the stacking model. So this is also one of the is ensembling method which you might have learned during your machine learning courses. Now, in order to talk about this ensembling methods and all, what you do is, let's say you generated three different models, M1, M2, M3. And using those models, you're gonna generate, basically you're gonna put this output to another model, maybe LR, and then get the output. So this is how basically we do it. But there are some problem with this. So when we generate these models, we don't take the whole data set. We take the subset of data set D dash. So we do take different data sets, so it works. Now the problem with this particular code is, though this basically this is called a stacking method. Okay. Now the stacking method works very well if you have a huge amount of data. But if you do have a very small amount of data like we have in this case, this may not work that well. So that's basically the problem with this. So since here we do have a small data, maybe the stacking model will not give us a good result. So you can see here that here basically we got the we are taking basically some models, and you can see here that I'm only taking my SVM because I'm taking the loss as hinge loss, and I'm taking another part which is basically my naive Bayes, and I'm doing all these things on one hot encoding. You can always feel free to do it on response encoding. So you can see here that we have chosen basically three models, and one is we have also chosen logistic regression. So logistic regression, linear SVM, and naive Bayes. These are the three things models we have built, M1, M2, M3, and after that we are going to build our stacking model. So this is quite simple, and once we got this, we can just look at our final log losses. So definitely you can see here that it is coming at 0.35, which is not that good if we compare with our older one. So if we go back and look at this, we already have got lesser than basically 0.35. We already have the KNN which is giving us. And at the same time, if we also go back and look at the log losses, so log loss is also coming at 1.11 on CV and 1.1 on this, right? So if you go back and compare, so definitely it is more in comparison to my these two loss. So I need not write it in my table now, because as I can easily see that it is not performing well, and that is what we were expecting also before, right? Because if you look at these log losses, definitely these log loss is not going to come to be good, because the reason is the data was kind of smaller in this particular case study. Now there is one more thing to look at after this. So once we have done this, we can also see the maximum voting classifier. As the name states, that it looks at, let's say you create three models, and from three models, whichever the log loss is going to be minimal, you're going to choose it. So that's a technique what it use. And again here you can see that we're gonna log loss by 0.19, but again you can see that my log loss is pretty high on the test set, 1.20. So this is again going to be very high, because we already have got 1.06, which is the minimal with us. And even if you look at the cross validation errors and all, this is also going to be higher. You can see that 0.35. Let's put this value 0.35, but we do have already lower value than this, right? So we need not again put this into this. So again, if we have to decide the clear winner, again we have to take a call now based on our evaluation criteria. So by the evaluation criteria, we should go for LR, which is one hot encoding with balancing, because we are getting 1.06 as my lowest value in this case, right? So it depends. If we are looking for accuracy, then my answer may change to KNN, because that is giving me 33.83. So it again depends on case to case. So like when we talk about, let's say, and when we talk about competitions like Kaggle, then in those cases we all kind of only target with respect to one parameter which we want. So there will be, you if you look at a leaderboard, somebody will have 1.07, somebody will have 1.08, somebody will have 1.06, like that. Okay, so whichever is going to be the minimal is going to be the winner. So that's how basically it works there. So with the testing data, they always look at and just kind of keep working on minimizing this parameter and see if they can basically win those competitions. This is how it works. But at the same time, what we have done in this exercise is very minimal. To be really frank, you can also do a lot of stuff. For example, on the text data which we have looked at, we very quickly kind of went to bag of words, right? We just used the const vectorizer and kept on working on that technique. But definitely you have so many things, like you could have gone to TF-IDF, you could have done so many other ways of splitting this data. Even the models what we have used some model with a basically response coding, some model we have gone for one hot encoder, though it is going to work in the same way. But still you can go ahead and even build those models with all the ways possible and see that which is going to perform better. So all these things you can anyway try. This was our attempt to give you an insight that how you can basically play with these kind of algorithms and basically come up with some solution, and even can target Kaggle competitions like this. But in real world case, if you're talking about, definitely you're not going to run behind just one method. That's the reason I have also taken the misclassified point for you, so that because in real world even the accuracy matters a lot. So in those cases we will be looking at the other stuff and do it. So in this case maybe we can give linear regression with balancing and say that okay, you can go ahead and use this into your production system, right? So this is the final output with this. So I hope you had a good learning with this particular project. Please give a good attempt to it. Please look at all the interpretability code which I have not explained in detail line by line, but definitely from your machine learning courses you might have already an insight how to do it up. If you feel that you have a better solution, please do it, and even let other people know. That's something which will also encourage. The main idea was to give you a good insight how to approach these problems, what are the parameters we look at, even what are the optimization technique we do, what are how to play with these hyperparameters. So these were the main motivation to look at this particular project. Thank you.